Dear Professor Galuchi, may I audible to you?
Okay. So still I cannot share the screen.
1 minute, 1 minute.
Okay, okay.
1 minute. कोठावडे सर स्टार्ट करूया का?
हाँ करा की सर, करा, काय प्रॉब्लेम.
Okay sir, thank you. Very good morning to you all my friends. It's my pleasure to walk you through the conference, introduce you to the speakers and delegates that have come from all over the country and also from other country to share their knowledge and enhance our mental horizon. Today's speaker and guest of honor, esteemed Professor Galuchi, foreign invitees and participants of the conference, my dear friends, ladies and gentlemen, I am immensely happy to welcome you all in second day of the e-conference and to Vidnyan Mahavidyalaya to the international conference on recent trends in nanomaterials and its applications. Friends, this is the first conference in the history of our college which is completely conducted on digital platform in line with social distancing norms due to COVID-19 pandemic. This is possible only due to the efforts taken by one of our ex-student of physics department, Dr. Sachin Navle from South Korea. Recently, he is honored by Marie Curie Fellowship Spain. I congratulate him on behalf of my college and my department. Now, I would like to introduce chairperson of today's first session of International Conference, Professor Kothawade. It is my pleasure to introduce Dr. Kothawade. Dr. Kothawade did MSc M.Ed from Shivaji University, Kolhapur and PhD from Babasaheb Ambedkar Marathwada University, Aurangabad. He is professor in Department of Physics, Sri Shivaji Mahavidyalaya, Barsi, since 1991. He did research on studies of rare earth substituted visco high TC superconducting compounds. He has produced one research student, while 5 PhD students are currently working under his guidance. He has published 11 research articles in well-reputed international journals, 7 research articles in national journals, and 2 research articles in the proceedings. He has written and published 18 textbooks. He has presented 21 research papers in national seminars and 17 papers in international conferences. He has completed one major research project, and recently he is BOS member in Computer Science, Solapur University, Solapur. He is NSS District and Area Coordinator from Solapur University, Solapur. And presently, he is BOS member in Physics and CRC member. 3 times he is honored by Best Teacher Award by different agencies and also by Solapur University, Solapur. He is also honored by Best NSS PO Award 3 times by Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. With this, I would like to conclude my speech by encouraging the delegates to participate with an increasing numbers in all the activities and the discussion through the digital platforms for the whole day. I wish everyone a successful, safe and fruitful conference, and at the last I invite Professor Kothawade to chair the first session of the international conference. Thank you, sir. Thank you so much. Professor Kothawade.
Thank you, sir. Good morning to one and all. I am very thankful to organizing committee for giving this opportunity to chair the session of International E-Conference. Vidnyan Mahavidyalaya Sangola organized International E-Conference on recent trends in nanomaterial and its applications, that is RTNA 2021. So I heartily welcome all in this session, Honorable Chief Guest, Dr. Missimilino Gulaji from SNES Institute of Advanced Technology, Chinese Academy of Science, China, all dignitaries, delegates, researchers, faculty members, student participants. I welcome all on the behalf of organization committee. Honorable Dr. S.V. Zundare sir, principal of this college, Professor B.B. Navle sir, HOD of Physics Department, Dr. S.S. Dasade sir, IQSC coordinator of the Sangola College, Dr. J.V. Thomre sir, convener of the international conference, and Professor A.M. Kamble sir, organizing secretary. This online conference is due to the COVID-19 pandemic situations, and we know whole world is facing this problem. So I request all the participants to take the care of our family, relatives, and friends. Keep physical distance when we are in social places. Use the sanitizer time to time, and also use the mask and avoid the crowd places. And remember, precaution is better than the cure. Follow all these things and take the care. Due to this pandemic situation, we becomes the techno savvy and digital, and also due to the online and internet, we can hear the scientists, researchers from any corner of the world. So Vidnyan Mahavidyalaya Sangola, given this platform or the opportunity to interact and discuss with the scientists, researchers, academicians from the various places. So again, I welcome all the participants in this conference. This is my privilege to introduce the today's honorable chief guest. The honorable chief guest is Missy Mileno Galuji from the China. He's completed his BSc in physics from the University of Milan. And at the time of the BSc, he completed the project on synthesis of nanostructured titanium dioxide thin film with the wettability control. And also he completed the MSc in physics from the University of Milan, and he has completed the project title Study of Morphological and Dielectrical Properties of the Thin Films of Ionic Liquid using the atomic force microscopy, and he has completed the PhD in astrophysics and applied physics from the University of Milan in 2014. And topic or the title of the PhD, interfacial properties of ionic liquids, electric properties of thin films, and interaction with model membranes and living cells. He has a vast research and teaching experience. Currently, he is a principal investigator, associate researchers at the Shenzhen Institute of Advanced Technology, Chinese Academy of Science, China. Also, he is associate professor at the Shenzhen Polytechnic University, Chinese Academy of Sciences, and also he is teaching the MSc course also, especially mechanics of the materials. Co-founder of He is a co-founder of 25% owner at G2 Polytechnic Cooperative Limited, Hong Kong. Research and development heat sink solution based on the graphite nanocomposite polymers. His work as an assistant researcher at the Shenzhen Institute of Advanced Technology, Chinese Academy of Science, China, and the research field was nano biomechanics, atomic force microscopy. So he worked as a postdoctoral research at the Shenzhen University, China, especially on the atomic force microscopy for the soft composite polymers and hydrogens. He has published 36 papers in international journals. His citation is 843. H index is 17. Google Scholar, and he adds number of the selected papers in international journal. He has won the number of scholarships, funding, acquisition, and other awards. Scholarship, President's International Fellowship Initiative, Chinese Academy of Science. This fellowship is awarded in the year of January 2019 to January 2021, and amount is 64,000 euro. Another scholarship, Overseas Youth Postdoctoral Introduction Projects, Gangjen Postdoctoral Talent Introduction Program, and this was awarded in January 2017 to January 2019, and amount is 1 crore 30,000 euros. Then the talent plan, excellent youth foreign talent from the Ministry of Science and Technology of China in 2020, and the amount for this scholarship is 25,000 euros. Then funding acquisition, National Natural Science Foundation of China General Program on the biomechanics of living microphages investigated by the automated atomic force microscopy. And this funding for this project 80,000 euro. Then he has get the another funding, National Natural Science of Foundation of China Foreign Youth Programs targeting the biochemical stability of lignocellular plant cell wall during the ionic liquids. And for this 50,000 euro is obtained. Then another funding acquisition, that is the SNES Science and Technology Innovation Committee General Program Biochemical Stability for the cell wall of lignocellulose plants during the perturbation of the ionic liquids. For that, 25,000 euro is allotted. Then the another funding from the China Postdoctoral Science Foundation, electrochemical coupling of the voltage sensing membranes pertain the investigated by atomic force microscopy. Then he has number of the awards. Director Innovation Award 2020, Shenzhen Institute of Advanced Technology, and amount is 1,500 euro. Second award, Outstanding Employee of 2019 in Shenzhen Institute of Advanced Technology, and amount for this award is 1,200 euro. Then the another award, that is the Excellent Postdoctoral Publication Award of the 2018 from Sneisen University, and amount for that award is 9,000 euro. He has given number of the invited talks on the different topics, and especially his interest topic is atomic force microscopy for advanced functional material in China, presented in 2019. Also, he has presented the AFM Biomed in 2019 in Mustard, Germany. Atomic force microscopy for advanced functional material, Nanjing, China, presented in 2018, and also atomic force microscopy Biomed in 2017 in Poland. So he has given number of the guest lectures and guest associate editor. He is a guest associate editor for the Frontier in Chemistry, Frontier in Physics, topic ionic liquids interacting at the solid-like interface from the inorganic surface to the biological membranes towards the bio nanotechnology applications. So, such a great personality with us, and his research interest mainly on the quantitative characterization of mechanical, electrical, and morphological properties by the atomic force microscopy. His research interest is especially on the atomic force microscopy. Such a great personality with us. So I welcome in this international conference to the Honorable Miss Milino Galuji, and I request to Galuji to give the guest lecture or guidance to our participants. Thank you.
Thank you.
Dr. Galuji.
Thank you for your kind introduction, Professor Kotole. I'll try to share the screen. Okay. Okay, so here at the beginning, they asked me to have like this advertisement for the International Journal of Scientific Research in Science and Technology before my presentation. So for international conference and the recent trends in nanomaterials and its application 2021. Here the resource person, Professor Patil, Professor Stadler.
Hello.
And here
Galuji. Hello,
Galuji.
Yes. One thing we have remember, we have to publish the proceeding of this conference.
Mm.
So I request Honorable Galuji to publish the proceeding of this conference.
Okay. This one, information for the proceedings.
Yeah, this one. This one. So you please you declare that proceeding is published.
Okay, so like an international conference on recent trends in nanomaterial and its application, 2021. So it's organized by the Department of Physics in collaboration with the Internal Quality Assurance Cell in Sangola, Taluka, Shetkali, Shikshan, Prasarak, Mandal Sangolas, Vidnyan Mahavidyalaya in Sangola. In then volume 9, issue 2, between March and April 2021. So inside the International Journal of Scientific Research in Science and Technology. Here, again, like the information. So that this international conference will be like in association with the International Journal of Scientific Research, Science and Technology. And here the resource person. Just going on, and then here the contents. So article and papers. So it will be like a synthesis of zinc-oxide nanostructure with the calotropsis, Procera leaf extract gain approach and its antibiofilm activity. Structural properties of manganese doped zinc-oxide nanopowder with the chemical co-precipitation, synthesis and electrical characterization of LSM thin film and cathode for SOFC, structural, morphological, and compositional properties of lanthanum 3+ substituted lithium cadmium ferrite by co-precipitation method, effect of annealing of structural, morphological.
Hello, sir. Hello, sir. Huh? Hello, sir. Hello. Hello, sir. Hello, sir.
Yes. Can you?
You just say that this proceeding is published.
Okay.
And then you start your screen or share your screen.
Okay. Okay. I will proceed faster. And here, so I thank all of you for like this invitation in the DC conference for the recent trends in nanomaterials and this application. So my name is Massimiliano Galluzzi and I work in the Materials Interface Center of SIT of CS. So already I've been like introduced like when I did like my education basically in Italy and then part of like Milan University in the north of Italy. With I work like in the of like molecular beams, and where I did like bachelor, master, and PhD in physics, working in atomic force microscopy. And then I joined China for my postdoc, where I work on polymers and hydrogel, and working in the group of Professor Stadler, where also I've been colleague of Dr. Sachin Nole. And then I joined as assistant researcher and finally associate researcher in the Shenzhen Institute of Advanced Technology, where I'm also professor in the course of like mechanics of material. So the background of like my center, Materials Interface Center, is about the production of 2D materials for interface engineering application and also the production of biochips. So in this framework, the characterization of such interface is like very important, and a technique that is commonly used for this characterization is indeed atomic force microscopy. So here I present some working principle. So basically, very sharp probe attached to an elastic cantilever, it can scan on the surface, and the vertical movement can be detected by a laser that is reflected on a photodetector, segmented. And while the scanner of the sample is a piezoelectric element, and then is scanning the surface with the nanometric precision. So in this way, it's possible to have the morphology of a surface with a nanometric resolution. So here, I will talk about the nanomaterial characterization through atomic force microscopy with some emphasis in the morphology, electrical properties, and the nanomechanics, especially then focus on the soft matter and the application on the living cells with then future perspectives. So here, the morphological features can be measured by the probe. And then always, when the probe is scanning the surface, there is a tip sample convolution, the meaning that the shape of the probe is always present inside the morphology. In this case, more the probe is sharp, and so with the nanometric side, can also see the feature of the morphological feature of the sample at the nanometer scale. In this case, also, the scanner is limited by the ratio of the tip while scanning. For example, when the probe is broken or there is something attached, these morphological features are then present inside the morphology. And this can produce like some artifacts as well. Scanning in air, there is always water capillarity adhesion that is increasing the force between the probe and the sample, and so there is a minimum indentation radius that can have some morphological effect on it. So here is an example of nanoscale morphology. And so why is important nanoscale morphology, especially for the characterization of example of electrodes, supercapacitor, or every surface where very high aspect ratio, very high roughness is important to increase the device possibility, the device capability. So more is rough and more there is the surface access on the same volume. So here there is an example of like a nanostructure titanium oxide, and then a typical image by atomic force microscopy in 3D and 2D. So the information by atomic force microscopy is always quantitative, so can be measured and then directly measure like a roughness to give a quantitative value for the characterization of the surface and then the production of the device. Here also I want to introduce something about conductivity properties, because when the probe is in contact with a sample, for example, the electrodes can close the circuit, and so the current can circulate. So the probe is forming a sort of nanoscale electrode, and then measuring the current, and then the resultant from the application of potential is possible to measure the resistance. So here there is an example when the probe is in contact with a gold surface that there is a ohmic contact, while when there is like a silicon dope with a native oxide, when the probe is in contact, only after reaching a threshold there is a conductivity, so a sort of diode-like behavior. While we did like some measurement on ionic liquids, like solidified ionic liquids, and then this is not conductive, and so we have like no conductivity. In this, we hypothesize that this is a dielectric film, and so the probe and then the AFM can also measure like the capacitance by switching in AC mode. We can have like something similar. So when we have like a macroscopic system, we have a capacitor where all of you know about how to measure the capacitance on a parallel plate capacitor, and from then it is possible to measure the dielectric constant using a nanoscopic system, such as like a probe with a conductive substrate. The model used is different, more complex, as you can see here. And while the probe is approaching to the surface, it's possible to visualize the contribution that are like linear coming from the cantilever that are like large. And then the last part near the electrode at the nanometers distance, where the capacitance has a behavior more than linear. So plus a logarithmic part. This part has a nanometric resolution. And then from this part can be done a calibration of the probe radius for the electrical contact, and then measure the electric constant. So here is an example of this two-step measurement focused on the capacitance of the apex of the probe. So the first step is used to measure the radius, as in this case, like a 200 nanometer. And then the second run here, you can see like on two different example on silicon oxide with a thickness 40 nanometer or 70 nanometer, where it's possible then to the fit measure the electric constant around like 4.37, 4.15 as expected for silicon oxide. So of course, then there are possible to do like many other AFM modes, because when the probe is in contact with a surface, it is possible to activate the other type of measurement. For example, measuring like the piezoelectric force, so for the polarization of material, as well like a surface potential during like the irradiation. If the probe is also magnetic, it's possible to do a magnetic microscopy to see the magnetic domains, and as well measure like the ions density distribution on the surface, the conductivity, as I explained like before, and also some innovative scan, like the scanning thermal microscopy to measure the thermal conductivity of a sample. Here also, now I want to focus on my like a specialty, that is using the AFM as a force sensor. So in this case, not only measure like the morphology, but apply force, and in this case, to retrieve the mechanical property of the sample. First, the probe is attached to an elastic cantilever. So when the elastic cantilever is deflected, a force can be applied and then can be loaded on the sample. This force, with using like a proper cantilever, can reach like 10 piconewton and with a deflection of like 1 nanometer. So this optical beam deflection can allow to measure this force vertically on approach, but even laterally by measuring the torsional mode of the cantilever. In this case, it is possible to have a friction measurement. Here I want also to give some highlight when using like the atomic force microscopy in comparison with the optical microscopy. So many of you know that when you use optical microscopy, you have like light feedback. The light is applied to see an object with magnification. But when using like biological sample, for example, cells, they appear like transparent, and so a staining is required. So this staining can be also some dangerous for like some delicate sample, like a biological. And in this also can have information about the shape of the cell, their morphology, and as well if the staining is located on some molecules, having information about the molecular properties of this sample. The atomic force microscopy has a touch feedback. So it means that the probe is in contact, and so when there is a force applied. In this case, no staining is required, so the sample can be seen natural condition as much as possible. And then we can have like some morphological information, as explained before, plus the mechanical properties. So having like information how much the sample is soft or hard. So the main and principal part of the for the measurement of the mechanical properties is the force curve, when the probe is applying a vertical force load. So you can see here when let's see if I can have a pointer here. So when the probe is like not interacting, is approaching to the sample, then is going in contact, applying a force until a certain point, where then the motion of the probe is reversed, and then is move away from the sample until it's detached, and then it's possible to measure this part that is for the adhesion between the probe and the sample, giving about some information if the surface is sticky, and then the detaching from the sample. So when this operation is done on a grid, regular grid on a surface, it's possible to have a force volume map, and then having a map of Young modulus that is giving like some intrinsic mechanical properties of the sample. So in this case also, the proper shape of the probe should be selected for depending on the sample. So here I want to give you like some example of FM nanomechanics. And so after like data analysis, it's possible to get information of Young modulus from very soft sample with a range around like 100 Pascal up to 100 gigapascal. So here is some example about like living cells, and that are around like 100 Pascal, 1000 1 kilopascal, and published on Langmuir. And then here an example of soft matter in liquid, where we embed like polystyrene sphere inside like a matrix of hydrogel in another range around like 10-100 kilopascal, up to system with a composite matrix of elastomer like PDMS with inside a graphene foam. And here you can see the mechanical map with the PDMS matrix with inside this graphene form appearing like much harder, and up to system very hard like ceramic material, and where the AFM can visualize the phase transition. For example, in the Martensite phase at 75 degree, there can be like some expansion, wrinkles, and then a decrease of density, and with a corresponding decrease of Young modulus that can be detected by atomic force microscopy imaging, mechanical imaging. So here I give like some hints about and some information about like using sharp probe. Sharp probe is very useful for like a very hard material where a lot of indentation is needed, but they have some drawback. For example, they have like a poor definition of geometry. So usually the model is using a conical model, but the probe is in reality like an asymmetric pyramid. Plus, it's very difficult to measure the nanometric size of the apex of the probe. Moreover, when acting on a cell, on a very soft material, the stress, the pressure applied, it can be like very high, and then can increase like the possibility to damage such sample. In comparison, this sharp probe can have also like high spatial resolution, as talked like in the morphological part, and the information coming from this measurement are like very local, so from a few nanometer on the surface. In this case, for a cell, it's not always good because for the cytoskeleton, it's better to have like some average properties. So here, using like a spherical probe is good to have like a good marriage, to have like a balance between like the resolution for the imaging on the cells and then a good nanomechanical output. So in this case, we can like have a good estimation of the geometry of the probe because it's a sphere and so very easy to measure. And plus the pressure applied to the sample is smaller, and then the indentation is gentle. And then a very easy model, linear model, can be applied like Hertz. And then on that one, on this kind of model can be like overlap some correction for measuring like the viscosity or the finite thickness when the sample thickness is little compared with indentation. So here, in fact, is like the physics behind with the Hertz model. And then, so by measuring like the indentation of the sample and then the correspective like reaction force, is possible then to retrieve the Young modulus, and also knowing like the Poisson like ratio. The Young modulus has intrinsic parameter of the sample. In this case, there are like some limitation that the sample must be like homogeneous and isotropic in all the dimension, plus should be like semi-infinite. So it means that the distance between the surface of indentation and the substrate, the rigid substrate, should be large with the indentation, as well to have like a pure elastic response. So when doing the measurement on living cells, these conditions are in a good approximation maintained. So here also, during like my previous years, I also designed a software that has a possibility to take the raw data from AFM and then specialize for like the mechanical measurement. So every force volume can be loaded, and then the single force curve can be visualized, as well as the how much like the fit is good, select the proper model and the parameters, and then on each section, where it's possible also to measure morphology adhesion, it's possible to have a statistics of the sample measurement, and as well the mapping. And then with like a easy click, this operation that usually for the data analysis can last like several minutes, in a few seconds can be done with like this software. Here, I also want to introduce some application of like these software and methodologies about like soft matter, especially about like heterogeneous hydrogels. So here you can see like some sketch of like finite element simulation, because in many cases when the AFM probe is indenting a complex structure that is heterogeneous, the mathematical model is not enough, and the complexity is too big, and so a model from like a finite element simulation should be created. Here we prepare like a simple system of like two phases of a sphere embedded on a soft hydrogel, and after the indentation on them, we perform like finite element simulation with different geometry, also trying to understand how is the interface between this particle and the gel. So the model of like free slipping, when the particles is not attached to the hydrogel and it can like rotate inside the matrix, or when there is a hard contact and then all the points on the particle cannot move. So in this case, we measure that the hard contact is the most suitable for describing like this system. So, and then here I want to talk about like my main research topic, that is on a very heterogeneous system, very complex, that is exactly like a living cells. So even if from the physics point of view can be similar to an hydrogel, is very heterogeneous because composed of different elements like nucleus, and as well the inside with different part of cytoskeleton. So the main topic is like why to measure like the mechanical properties of the cell is to have like a fingerprints of the status. And the status is connected by on the cytoskeleton. So when the AFM is measuring like the cytoskeleton, how much is like cross-linked, and how I interacting like these parts. So the cytoskeleton is important for the structure of the cell to maintain like this volume, but as well also for the movement, because by polymerizing and depolymerizing the molecules of cytoskeleton, the cell can move, can also differentiate, govern like the signal transduction, and as well move the organelles inside. So the AFM can have like information about like morphology, and then the modulus map. You can see like in this map that already there can be visible some parts that are like heterogeneous inside the cell, for example, organelles and nucleus. So why it is important also? Because of the biomedical relevance. One important part is about like the cancer research. So AFM can measure like the cancer cell, especially when they are interacting with the extracellular matrix, ECM. And then it was experimented that the cancer cell in vivo and in vitro, they have like a different behavior. They have a different mechanics because they can modify the cytoskeleton differently. So the possibility for like AFM to detect and measure the organization of cytoskeleton is very important. As well, how much is like proceeding the interaction between like the extracellular matrix and the cancer cell is important for the malignancy of cancer progression. And then it was so that experience that when the stiffness, the surrounding stiffness of like cancer cell is increasing, then there is also the possibility of promote malignancy so that the cells are detaching and then forming metastasis. So here, then I measure like the importance of like the environment on the organization of cytoskeleton, and especially I work on ionic liquids as an environmental drug. So yesterday, for example, Professor Stadler presented how the antibiotics can be dispersed in the environment and how to get rid of this pollutant. Ionic liquids are usually used as innovative chemical compounds. As well, they can be used as like electrochemical liquids for cells, batteries, and because they are salts that are liquid at room temperature, so they have like ionic conductivity. Between like all these properties, these ionic liquids are like not volatile. So this is like a green color because they can be applied like in green chemistry because they're not volatile and so they are like no pollutant. But the situation is reversed when these can have like an accidental spill in water environment or even contamination of soil. So because they are like not volatile, they cannot get rid easily. So it is important to have a risk assessment and also for like a production and application as a solvent in the future. So here, so I measure the mechanical property of a cell when they are like interacting with an ionic liquid to check how is like the fingerprints of modification of cytoskeleton and then connect it to the status of the cell. So here you can see when they have like a low carbon tail, they have like no effect at low concentration, but at high concentration, they produce like a big damage, causing like apoptosis, so death of the cell. And then we have like a fingerprints because the cell stiffness is increasing. For like a long tail, they are like even more toxic for like a low concentration, and also they are interacting with the external membrane, and so there is a decrease of the mechanical properties promptly detected by AFM. Recently, also when there is like a very low concentration but a long time of interaction, we did also an additional measurement. And here you can see like the preliminary measurement on confocal microscopy. These liquids are forming like an internal vesicle covered by actin. And then so there is a mobilization of the cytoskeleton, forming this structure that are like autophagosomes that are used for the to eliminate, to retrieve the damage that is done on the cell. So it is forming like a vesicle when the cell is recovering like from the damage, and also the data that we are like acquiring now is about like the increase of the mechanical properties because of like the mobilization of actin cytoskeleton. So also here, another example of what happened when we have like nanoparticles and, for example, hydrogel nanoparticles, nanofibers interacting with macrophage. So macrophage are like cells of immune system. They can move and then they can internalize these nanofibers. Nanofibers that are like some micrometer long, but with a fraction of micrometer in thickness. So here we apply like a complex technique doing like a correlative microscopy. So AFM with fluorescence at the same time. So we can visualize the particle as well as the distribution of actin. Then we did like AFM and then the finite element simulation to have an information about the coating of the actin. So when these nanoparticles are internalized, the cytoskeleton is moving this particle internally, and then when it's moving, it's covering by actin, and then AFM can measure like a different density of the cytoskeleton. We measure this different density, and so we can have an estimation about the forces that the cell can act on these nanoparticles. This is important because by tuning the stiffness of this nanoparticle during the production, it's possible to use nanoparticles with a stiffness similar to the cytoskeleton accumulation in order to produce an innovative drug delivery system. And then finally here, I present like something when we apply like the cell on a nanostructure surface. So here, in some previous studies, we apply like neurons on a nanostructure surface, like zirconia or titanium dioxide. And then we noticed, the FM noticed that there is a decrease of the stiffness when applying on on the nanostructure surface, plus without any chemical stimulation, the neuronal cell make a differentiation, producing like the neurite, that is like a indication that is a maturation of the neuronal cell in the mature phenotype. In this case also, we continue like the research, basically confining these neurons on nanostructure patterns, nanostructure patches. So these neurons can be confined, and then they are forming, thanks like to the possibility they can differentiate on the nanostructure, like bridges between.
Provost is not allowing participants to unmute themselves.
Can form like these bridges, and then we measure like a communication, electrochemical communication between like these bridges. So with like some future possibility about producing artificial neural networks. And finally, I want also to give some hints about like my current and future work plan. That is, if it's possible, because one of the drawbacks of AFM is that the technique is slow. So AFM image, mechanical image at high resolution can also employ like 40 minutes of measurement, and then this is not so feasible for cells that are alive. So in this case, the plan is like to join force with artificial intelligence, like deep neural networks, to make automatic AFM. So we already have experience on a correlative atomic force microscopy and tracking of between optical and the AFM. And so we are producing a software with a possibility to perform force curve only in selected location. And so in this case, we can have a good measurement setup to decrease the timing to perform like the measurement. And then finally, we can use this for biomarkers for disease, for diagnostic, that is like with a timing comparable with the standard diagnostic technique. So here, like a very recent preliminary results in this field, where we collected several macrophages with different phenotype. So it's the same cell line, but with different like phenotype formulation. So M0 are like resting, M1 they are like activated for the fighting pathogens. So macrophage, and the M2 they are like for like regeneration. So as you can see, the morphology is different. While there are like some appendages for M0, M1 the shape is like more circular and flat, while M2 is like linear with 1D polarization. And as well, the mechanics are different and can be easily calculated by AFM. So we apply like a preliminary deep neural network for the discrimination, automatic recognition of these cells. And then we measure that just using like the morphology for AFM, we obtain 89% accuracy. If we add morphology and adhesion together, we have a decrease of accuracy. Why? Because adhesion is not well defined for these cells. Moreover, they are similar for different kind of cells. So the signal is not helping, and even the artificial intelligence is getting more confusion. So the accuracy in the automatic determination is decreasing. Oppositely, adding like the mechanical feedback, the accuracy is increasing up to 96%, because the mechanical is like very well defined, and then it can help for like the discrimination of the cell type. So here I also want to introduce something about like my team, like a master student that is working on like some peptide interacting with the cell, as well a candidate master student that is working on a biological and a plant cell, mechanical part of plant cell, as well the fruitful collaboration in Hong Kong University, where we are developing like this correlative microscope. So I acknowledge like several funding between like the PV Fellowship and the National Science Foundation of China and the Shenzhen City Innovation Committee, and plus like the director of our center that we have like 16 more people. And finally, I also want to something about like recruitment, because I'm always like trying to recruit like people that are interested in AFM characterization. So right now we have possibility for like master student in UCAS and the new university that we are establishing, as well PhD student, plus with the possibility of like ANSO scholarship and UCAS scholarship, as well like a postdoctoral scientist with the PV fellowship from Chinese Academy of Science. Of course, when the situation will be better and the Chinese border will be open again for traveling. And with this, I conclude like my presentation. If you have any questions or curiosity, I will be happy to answer.
Thank you. Thank you, Gulaji, for a nice presentation. You have presented very nice and new topic. You have in specialization of atomic force microscopy and use of the atomic force microscopy to study the various properties of the nanomaterial, especially that is the mechanical properties, then the conductivity and dielectric properties of the materials. So very nice and new work you have presented here. So on the behalf of the organizers committee, I am very thankful for presenting or the giving this talk or the lecture. So thank you once again.
Thank you.
If you have any participants have any question or the query, they can put the questions in chat box. One question from the participants from Dr. Shivanand. He want to know if there is a porosity or the defects in the material during the synthesis, then how much it will affect to the capacitive measurements or the property of the nanomaterial.
So if there are like some yes, so during like the production of the material, there can be like some maybe contaminants on the surface, and so in that case, yes, there can be like some modification of like the electrical properties, and the thing is that it's very difficult to measure like a very thin material, like below 5 nanometer, because there is like not so much difference on the capacitive measurement between the pure electrode and the very thin sample. And in that case, if there is a contamination of like a few nanometer, and then the thickness of the film is around like 50 nanometer, then it can be, the contamination is like negligible. If the contamination is like comparable with the thickness of the film or a fraction of the thickness of the film, then yes, there is a modification in the electric constant, usually like decreasing. For example, let's go here.
Dear sir,
Yes.
there is one more question. What sir?
Okay.
There is one more question in chat box asked by Professor Rajkumar Rajure. He is asking about what is the probe material which is used, what is the tip height, and he is asking about the length of cantilever.
So for this measurement, for the electric measurement, it depends for like the electric measurement, the probe has a conductive coating. So the best coating is like the platinum iridium, or we have like a heavy doped diamond, because heavy doped diamond is tough, and then it cannot be like destroyed easily during the scan, and so they can be like used also several times. And in this case, for like the length of the cantilever, is like I would say like 200 micrometer, even less, like 100 micrometer. And anyway, like the length of the cantilever, it depends on the spring constant. So longer the cantilever, you have like a spring constant lower for having like a gentle touch. So for like soft material. For the length of the cantilever is becoming smaller when the spring constant is increasing, and then is used for very tough material in that case. For the other measurement on biology, we just use like a silicon or silicon oxide, because we don't need like a special treatment for a conductivity measurement.
Okay. So another question is, sir, you are working on the cancer cells treatment also. So the material which you have prepared, it is applicable to the cancer, or it should be able for the that cancer?
I'm sorry, I didn't. The signal was quite bad. Can you repeat the question?
Okay. Question is that you are working on the cancer cell. So
yes,
the material which you have prepared, that material should be applicable to detect the cancer cell, or that material is used to cure that cancer.
So for example, with this material that we use, and basically at the moment it was not like for curing like the cancer cell, or like detecting. At the moment, what we did is a sort of empty box. No, and then these they are like hydrogel nanoparticles, so they didn't have any like medical compound inside. At the moment, what we are interested in is to have a sort of nanometric box where probably in future they can be like a delivery of like an anti-cancer drug, for example. And while for the detection of the cancer, basically we don't need any treatment. At the moment is only like for detection. So we have like the pure sample, then the probe is just a standard probe, and only through the mechanical measurement we can have like information about like the cancer, what is like, for example, the stage. So this is just an example. So different kind of cancer cell, they have a mechanical response that can be different, even depending by the environment. Okay.
नेटवर्क प्रॉब्लेम कोणाचा आहे? जगन.
Am I audible?
Yes. Speak on, sir. Okay, I think so far that Dr. Kotawade's network is unstable. Now, I would like to conclude this session by vote of thanks. On behalf of my college and organizer of this international conference, I am very much grateful and thankful to my friend Professor R.R. Kotawade for chairing this session. It is our great honor that we are here with eminent personality like esteemed Professor Galuchi. I am very much grateful to Professor Galuchi for his very nice and excellent and valuable presentation. Thank you, and thank you so much. Here it is the end of first session of the second day. Now I would like to hand over this session to Professor Ashok Kamble. Thank you.
Am I audible?
Yes, sir, it's audible.
Okay. Dear participants, this is the oral presentation sessions. Now today's chief guest is Dr. S.D. Patil, that is Swati Patil. So it's my great privilege to introduce the chairperson of the oral presentation. So she is working as assistant professor in physics and head of the department at Pratap Singh Mohite Patil Mahavidyalaya, Karmala. She has done MSc and PhD. She obtained PhD from degree from the Dr. Baba Saheb Ambedkar Marathwada University, Aurangabad. Title of this PhD thesis is Studies on Synthesis, Characterization, and Physical Properties of some Spinal Ferrites. Madam has been teaching experience more than 10 years. She published 5 national and 13 international research papers in reputed journal. Also 3 research papers in the proceeding. Madam presented research papers in 2 national levels and 5 international levels. Madam has Google Scholar citations 758. H-index is 9 and I-10 index is 40. She is holding so many administrative responsibilities at college levels and university levels. I welcome again Dr. Swati Patil for today's oral presentation sessions. And please chair the sessions, madam.
Okay, thank you, sir. I thanks to organizer of organizing team of the international conference and give me such opportunity to chair this session. Good morning, all of you. I will call first oral presentation. Miss Sushma Kulkarni, please start your presentation. I call Miss Sushma Kulkarni for oral presentation.
Yes. Am I audible, madam?
Yes, yes, ma'am.
Yes, okay, okay. Okay. I am Dr. Sushma Kulkarni from MHE Arts, Science and Commerce College, Malegaon. And first I would like to thank the organizer of the conference, Recent Trends in Nanomaterials and its Application. And my presentation topic is Synthesis of Indium Oxide Nanopowder by allobarbandicys Miller extract and its application as a S2S gas sensor. My content of the presentations are introduction, experimental techniques, result and discussion and conclusion. Now first I would like to explain the need of sensor. The numerous kinds of the gases are emitted from various sources affecting our living place, working space or outdoor, many of these being hazardous to human being and environment. There is an immediate need to diagnose them. And now, why S2S sensor? Because the high concentration of hydrogen sulfide exposure can cause a deep health effect on human respiratory system and could induce neurological sequelae. Therefore, for protection of the human health and environment, detection and monitoring of H2S is necessary. Now here in this my paper, I have chosen material indium oxide, that is iron 203. It is a semiconductor metal oxide which has attracted remarkable attention due to its interesting property such as a wide band gap, that is 3.6 electron volt. It has good electrical conductivity, high transparency in visible and near infrared region. It has been widely used in organic light emitting diode, solar cell, gas sensor, batteries, and transparent thin films. The core hindrance in the usage of this material is its cost. The method that researchers have focused on the development of such an oxide have been economic and environment friendly for synthesis of nanoparticles. This aloe vera plant, or which is widely known as allobarbandicys Miller species, this is the perennial succulent belonging to Liliaceae family. It is a cactus-like plant that grows in hot and dry climate. Aloe vera, which is well known, it possesses anti-inflammatory, UV protective, immunomodulating, anti-protozoal, and wound and burn healing promoting properties. Today, aloe vera gel is active ingredient in hundreds of skin lotion, sunblocks, and cosmetic. And in the particular of this project, I have selected aloe vera barbandis Miller species from my region, that is in Nasik district, and particularly these there are total 400 species. Out of that, whatever the species I have chosen, which have the orange color flowers, that is its identity. I will synthesize this nanocrystalline powder. I have taken the aloe vera leaf pulp, and I have taken this leaf pulp and weighed it 35 gram. And before taking the pulp, I have washed that leaves very thoroughly with water. Then this is cut into finally, and it is boiled in 100 ml of distilled water. And then I have used the 2,4-pentadionate. Another name is acetyl acetone, indium acetyl acetonate. And now then I heat and stir the solution at constant 60 degrees Celsius until it is dried. And now then it is having the brownish color, and then it is crushed, dried into the powder using mortar and pestle, and then powder is calcined using the muffled furnace at different calcination temperature. Here in this experiment, I have chosen a temperature 450 degrees Celsius. And now that brownish color is turned into yellowish colored powder. Now then I can confirm this. The powder is formed by using the XRD spectra. That XRD spectra has been taken from 20 dark angle. Here, this reflection, whatever I got here, that is indexed into JCPDS card number 060416, and I use the D Scherer formula. Can be known from the XID of the powder sample. Then I have taken the transmission electron microscopy, that is TAME, for morphological study, and here that we get a spherical
Ma'am, your voice.
the said pattern, and in that case we find here a clear this ring, and from this it is known that this is a completely crystalline material, and it shows the that is HKL 222, and this major interplanar spacing from this said pattern, it matches completely with the JCPDS XRD 060416. Use this powder as a functional material, and functional using a simple screen printing technology, I have printed the thick film on the alumina substrate. This I have shown here my thick film, and I have used alumina as a contact for the further gas sensing purpose. And here, this is the size that you can see the yellowish color, and this is for the contact purpose. And this is the screen printing technique that I have shown. And once that films are formed, I have fired that film at 600, 700, and 800 degrees Celsius. Now, again, here we find as the firing temperature increases, the size of this peak that becomes sharpened. That means the crystallinity is increases, crystallite size increases. And here we measure the crystallite size using the D Scherer formula that was found to be 13 nanometer, 14 nanometer, and 16 nanometer. That is 13 nanometer for film fired at 600, 14 that increases for 700, 16 for 800. And after that, we have optimized the film. And before optimization, I have taken the same images, and from the same images, it is clear that these size of the crystal that get increased at the firing temperature increases. And here we find there is a agglomeration of the particles. Some voids are formed again because due to use of organic vehicle that evaporated during the firing. And now this is the simple gas sensing unit that I have used for my experiment, and I measure the resistance in the presence of the air and in the presence of the gas. And now that can, I use the micro syringe for injecting the 100 ppm H2S gas. And now after in this, I measure the resistance and the change in the resistance that give the sensitivity. Now here, this is the graph of the film sample fired at 600, 700, 800. And here we got a maximum sensitivity for the film fired at 700 degrees Celsius. That we found it is having the low resistivity, high sensitivity, and this is our optimization that I have used the 700 degrees Celsius film for the studying H2S gas sensor. Then I take the film was kept here. I got here the maximum temperature that I get to pick, that is at temperature 150 degrees Celsius. That 150 degrees Celsius is optimal temperature. And then keeping that optimal temperature constant, I use the different ppm of the gas that is injected, and the sensitivity is measured. Here, that picture is not here. These are the parameter which is shown on the x-axis is the ppm, and on the y-axis is the response or the sensitivity. And now the film was kept constant at optimal temperature, and different gas concentrations were injected into the test chamber, and the sensitivity, it is increases linearly up to 200 ppm, and afterward it attains the saturation level. And now we got here the excellent response in the case of this sensor, and this is the response time. It is a 6 seconds, which is very quick, but it takes a longer time for the desorption, and due to that we get that is recovery time is longer. And now here in the sensing mechanism, generally the atmospheric oxygen that acquired the electron from the conduction band of the indium oxide and O- species are present on the surface. So the resistance of the sensor initially increases from that O gas twice E, O2 adsorb. Then the reducing gas, that is H2S here, it reacts with the O2- species, and this releases the electron back to the conduction band, and they form the reducing oxide. And then this H2S gas react rapidly with the adsorbed oxygen. This reaction has been shown here, and in that case there is the formation of water molecule. 6 electrons are that is in these 6 electrons are released, and therefore we can say here the resistivity that get decreases, means the conductivity increases, and here we get a maximum sensitivity for the H2S gas. Now our conclusion is that this nanocrystalline powder of the pure indium oxide, it was synthesized successfully using simple, cost-effective and eco-friendly route using aloe vera plant extract. Here XRD and EDAX, it confirmed that the synthesis is viable and complete. The TEM analysis showed that the spherical shaped particle with a size 20 to 27 nanometer and IN2O3 film have been deposited on an alumina substrate using the screen printing technique. It was found that the film fired at 700 degrees Celsius, it offered the low resistivity and high response. The XRD study revealed that the polycrystalline morphology of IN2O3 thick film and its grain size increases with increase in firing temperature of the film. The sensor fired at 700 degrees Celsius, it exhibits highest sensitivity toward H2S gas at operating temperature 150 degrees Celsius. Sensor exhibit excellent response of 6 seconds, but it took 30 minutes to recover its initial value, and a detailed study is needed to convert this sensor into commercially viable device. And in this case, the thickness I have measured using the profilometer. The thickness varies between 16 micrometer to 18 micrometer. And these are my references. And thank you for your kind attention.
Thank you, madam,
Okay.
for your presentation.
Okay. Thank you, madam.
Okay.
Any difficulty?
Nice presentation, ma'am, and nice work. Anyone have a question? Please ask. Anyone have a question? Please ask. There is no question in chat box. Okay. I think no any question. That means ma'am's presentation is very much grateful. This session is open for question and answer. No anyone question? Okay. Now we move towards the next presentation. Next, may I requested to organizer to start recorded video presentation of Mrs. Gawande ma'am from Sangameshwar College, Solapur.
कमी येते इथे आवाज कमी.
डिवाइसचा किंवा सिस्टीमचा आवाज वाढवला.
Kamble sir,
Yes.
there is no sound, sir.
Yeah, I think the sound is not working properly.
Only slides are moving. What happened?
Madam, I think the original sound is not sufficient. That is why it is too much less sound. Please conclude the session.
Okay. I thankful to Gawande ma'am for his presentation, and I also thankful to organizer for giving me such opportunity to chairperson this session. Also thankful for convener to give me this opportunity, and I hand over the session to Kamble sir.
Thank you, madam. On the behalf of organizing committee, I would like to thank Chairperson Dr. Swati madam. Such a nice presentations are there. I would like to thank Dr. Sushma Kulkarni ma'am also, and the presentation of Gawan madam from Sangameshwar College. Such informative presentations. So thanks, madam. Thank you. Okay. So now we are going to start our last session, valedictory function. So on the behalf of organizing committee, RTNA 2021, I welcome you all to valedictory function. So first of all, I would like to request Dr. J.V. Thombre, convener of this e-conference, to share the conference overview.
Thank you, sir. The president of valedictory session, beloved principal of our college, Dr. S.B. Dundre, sir, chief guest of the conference for the valedictory session, Dr. R.T. Sapka, sir, vice principal, Tujaram Chaturchand College, Baramati, guests from abroad, Professor Stadler and Dr. Massimiliani Galoji, and participants in the conference. My dear friends, ladies and gentlemen, I am presenting here report of International E-Conference on recent trends in nanomaterials and its applications, that is RTNA 2021, held here by Department of Physics and IQSC. I reiterate my gratitude to Honorable Principal and IQSC Coordinator, Dr. S.S. Dasare, sir, for planning this conference as an e-conference on Zoom meeting platform. I thanks to my colleagues in the Department of Physics for entrusting the responsibility of organizing the conference to me. This conference was attended by more than 200 participants. The conference was consisted of 5 different technical sessions, including 2 sessions of oral presentations. The keynote address was given by Professor P.S. Patil, sir, who is Pro Vice Chancellor, Shivaji University, Kolhapur. He has mentioned the importance of nanotechnology in the field of nanotextile industries. We have heard 2 invited talks by Professor Stadler and Dr. M. Galoji. Both are from Shenzhen University, China. Professor Stadler has mentioned the photocatalytic activity for water purification. And recently, the the invited talk presented by Dr. M. Galoji has explained the importance of atomic force microscopy in nanotechnology. The invited talks, it will be helpful. All the participants, they will apply all the new areas to various fields of their own research. The invited talks given by Professor Stadler and Dr. Galoji, these two foreign invitee, has presented their talk on the Zoom platform because of only Dr. Sachin Naule only. So my sincere thanks goes to Dr. Sachin Naule for their cooperation and for planning this conference also. Dr. Babar AR and Dr. S.D. Patil, both these are the alumni of our department, and they handle the sessions for particularly oral presentations. So I have to express my special thanks to both of them. Considering the huge response that was generated, we had to join participants on Zoom platform. Surely there must have been some lacuna. I apologize for the inconvenience caused. The conference is coming to an end, and with a heavy heart, I bid farewell to you. I will keep meeting through the pages in journal and also through many more such conferences, some of them again in Vidnyan Mahavidyalaya, Sangola. So goodbye and thank you. Thank you, sir.
Thank you, Dr. J.V. Thombre, sir. Then feedback from participants. I invite Dr. A.R. Babar. Dr. A.R. Babar.
Am I audible, sir?
Yes, yes, yes.
Good afternoon to all. Myself, Dr. Babar A.R., Assistant Professor in Physics at Shankara Mohite Mahavidyalaya, Plus, and ex-students of Vidnyan Mahavidyalaya, Sangola. Herewith, I am expressing my views about the International E-Conference on Recent Trends in Nanomaterials and its Applications, RTNA 2021, organized by Department of Physics in collaboration with IQAC during 9 to 10th April 2021. The organizers have organized wonderful lectures, including keynote address by Professor Dr. P.S. Patil, sir. Every participants have benefited from all the lectures. Also, organizers have published a conference proceeding in the journal, so it is very useful to participants. Also, all the technical sessions are informative and all are arranged in time. So it is my great honor and I feel proud I am the ex-students of the Vidnyan Mahavidyalaya, Sangola. So with these words, I am very much thankful to organizers who have given me opportunity to express my views about the RTNA 2021. Thank you very much.
Thank you, Dr. Babar, sir. Now, anyone from participants? Okay. Okay. Then it's my great honor to introduce the chief guest of a valedictory function. And the name of our chief guest is Dr. Ramchandra Tukaram Sapkal. He obtained his MSc, MPhil, PhD from Shivaji University, Kolhapur. He is working as a vice principal and assistant professor in physics at Tuljaram Chaturchand College, Autonomous College, Baramati. His area of research is thin film physics, water purification using nanomaterials. Title of the PhD thesis is Photoelectrocatalytic purification of water using spray deposited zinc oxide thin films. He has been teaching experience more than 25 years. He attended orientation courses to refresher courses, winter school, short-term courses, etc. Dr. Sapkal sir published 6 research papers in international journals and 6 national journals, national level journals. Sir has written 5 books, national and international levels. He presented the research papers in 9 international, 10 national levels conferences. He completed 3 minor research projects from various funding agencies, and it's cost around 7 lakhs. Dr. Sapkal sir works as a resource person in refresher courses in experimental physics. Sir delivered invited talks in 9 times in the international conferences. His Google Scholar citations is around 235. He is a research coordinator of Center for Innovative and Applied Research. He is holding so many administrative responsibilities such as vice principal, member of NSS committee, IQAC chairman, NAC coordinator, counseling sales, ISO steering committee member, coordinator for CPE, College for Potential Excellence, proposal writing committee, etc. Academic and research coordinator at university level. With this brief introduction, let me invite to Dr. R.T. Sapkal to share your valuable thoughts on the occasion of e-conference, international conference. Thank you. Sir.
Hello.
Yes, sir.
May I audible?
Yes, sir. Yes.
Yeah. Namaste. Good afternoon, all of you. And thanks for a nice introduction by a compressor. We gather on e-platform in validatory function of a 2 days international conference on international e-conference on recent trends in nanomaterials and its applications in 2021. Organized by Vidnyan Mahavidyalaya, Sangola. In this function, I respected a principal, Dr. S.B. Dundre, present here. The convener of this conference, Dr. J.V. Thombre, a good friend at the University of Shivaji University at the time of my research work. Organizing secretary of this conference, Professor A.M. Kamble, is my student at TC College. The head of Department of Physics, Professor B.B. Nowle, sir. And my friend, IQC coordinator, Dr. S.S. Desade, sir. And different distinguished research persons, especially Gulazi from China University. Just now, very nice presentation in morning to all students and researchers and scientists. And different distinguished scientists, professors, researchers, and all students from all over the Maharashtra and especially from your college. And chairman and of Sangola Taluka Shetkari section Prasar Mandal, by the support of this society section Samstha, this conference is firstly I congratulate the organizing committee to organize on such a title recent trends in nanomaterials and in application. So today's need, the societal need, what are the different types of top 10 problems in society? Why these nanomaterials are they playing a vital role in this societal question? Now, these nanomaterials, how these used for a society, and therefore in 20th century, there are the major global issues that we have to focus. Which are these? These are the cross-cutting issues nearby our working places. Then a food, biodiversity, and land issues are the very important in this aspect. So the food safety and food security, how these nanomaterials are used in food safety and food security concerns. Now, conservation and integrating of the biodiversity. So biodiversity is the very important main topic for these environmental issues. Now, the boosting the urban sustainability, how different problems can be sustained at the urban as well as the global level as well as the village levels. Now, the fresh water is the main a problem in everywhere now arising, and that is because of the water pollution and our marine issues are also this one. Now, there is another issue, that is the climate changes issues. So globally, the whole world is thinking on that a climate change. Now, and next one is the energy. So everyone is rushing about the thinking about the synthesis, the new materials to find out how my material is used in the energy sector. So maybe it is related to the batteries, maybe it is related to the solar energy, maybe it is related to the heat energies and new technologies, and the wastage of the industrial wastage is a very important according to that. Next one is the medicine. So how, and we are facing just a pandemic COVID-19, how the medicines are the important for human lives. Another, we all are the very peculiar and very near to the agriculture. How that nanotechnology, nanomaterials are used in the agriculture and industrial growth without the pollution. We have to focus on the industrial areas, to grow the industrial areas. To stop the industrial area is not a solution. To grow industrial areas without the air pollution, without water pollution, without the sound pollution, and without emission of the CO2 and the greenhouse gases. And how it is possible? It is possible using the nanotechnology and nanoscience and new materials synthesized by. And last one, the global issue, that is the human resource management, is very important. And today India is also facing human resource management, because there must be a work for the every hand, every skilled hand, and therefore the government of India is launching the very interesting and very important themes, that is the skill Indians, skill orientation courses, the skill certificate courses at the colleges and universities also. And therefore, all students and the researchers are focusing on the new nanomaterials technology to solve these global challenges and global topics in this. Then we have to focus on which emerging technologies are incoming between the 20 and up to the 30. So our national policy is changing, our educational national policy is also going on changing, and therefore as being a student of science, as being a scientist, we have to focus on which emerging technologies are coming, and therefore these are the micromedicine, digital medicine, and virtual revolutions in medicine. Just now we are all world is facing this pandemic situation, and how to solve this one. Another emerging technology is coming, that is the sun powered physico-chemical war. The energy extract from the sun and use for the daily life, use in your agriculture, use in the vehicles and so on. And therefore another is the special computing technology, and a big data analysis. This area is very important for the student point of view. So how to analysis is done using a big data analysis, using the different softwares, and in the either they may be in the materials, in maybe the industrial, in maybe the analysis purpose of this. And electrical revolution is coming. All your diesel and petrol will all stop, will cars will stop, and that will starting on the batteries, and therefore electrical evolution will come, and low carbon cement, quantum sensings, and green hydrogen, renewable energies. So these are the coming technologies within the next 10 years, and therefore all students and ourselves be the ready to cope these or take the advantages, or focus on this one, or you adjust yourself to these technologies. At present, I will say that think globally and act locally. So that the local needs and local problems will be solved at a local level only, and that is the Atmanirbhar Bharat. So to Atmanirbhar Bharat, so this concept is introduced by our government, and therefore think globally and act locally. And therefore, I appeal to all students and researchers to find out the top 10 problems at your areas, not globally. Find out the 10 problems in your village, find the 10 problems in your taluka, find the 10 problems in your the district, find 10 problems in your the city, and what are the solutions? So these solutions in your the college laboratory. Go to the laboratory and discuss with your the teachers, discuss with your the guides, and find out the a problem for the at a local level only. And therefore, each a college act as the a laboratory is the source of a solution, and such that go to the your local industry areas and find out the 10 problems from that, and probably from the farming also. And therefore, I must be say that there must be the incubation center at each college, and the students should come with innovative ideas to the incubation center, share with the incubation center, share with your the teachers, and find out the solutions in this one. And this international conference is a right platform, and is a right source new for the new ideas for synthesis of the materials. So I also give the one message. So don't stop only for the synthesis. Go for its application. Once we going for the application, where to use my material, and for that you required the what are the solutions. Your material, your ideas, your innovative ideas must be applicable for the local level and at the global levels also. So with these words, I thank organizing a committee, and especially all organized convener and Principal Chondre sir to invite me as the chief guest in the valedictory function. Thank you, sir. And thank you to all. Over to Kamlesh.
Thank you, sir. Thank you very much. Such a nice informative thoughts on share with us. And also, what are you say? What are the challenges in front of the researchers and new researchers? So nice, sir. Thank you. Now, I would like to request Dr. S.B. Jundle sir, our principal, for the presidential remark.
I welcome all of you in the valedictory function, which is the second day of the international conference. As in the inaugural function, I said that Sangola is the drought-prone area having rainfall 500 to 600 mm. And hence, farmers in Sangola, they are growing a good quality of pomegranates, which is one of the cash crop. That is the speciality of Sangola land and of the farmers also. Also, Sangola is famous for specific variety of cows and bullocks known as Khilar variety. Sangola is also famous for the goat variety known as Madugul Shiri in the regional language. Sangola Taluka Shetkari Sahkari Sudgirini is also famous, which is running in profit from last 40 years. Lastly, I will quote the name of Dr. Ganpatrao Deshmukh, the ex-MLA who has won the election 11 times, and he was 50 years as a MLA of Sangola constituency under the same party known as Shetkari Kamgar Paksha. Also, lastly, I quote the names of some poets and novel and cinema script writers in Sangola and Mandesh area as Gadi Madgulkar, Venkatesh Madgulkar, Sridhar Swami, Shankarao Kharat, Krishna Ingole, Anil Launjal, Santosh Dongre, and so many others also. These are 5 peculiarities of Sangola Taluka and Mandesh area. Though there is shortage of water, but nature has given some additional strengths, just as I said. Vidnyan Mahavidyalaya is located in such a situation. Physics department and IPSC has organized 2-day seminar on recent trends in nanomaterials and its applications. Theme of conference is suitable as per the need of time. Resource person Dr. P.S. Patil, who is working as a Pro-Vice Chancellor of Shivaji University and which is the administrative post. Along with these responsibilities, he has maintained his interest in research. I hope that he and his team will be succeed in investigating nanoparticles. Just spraying on the dress, there will be a strong shield which prevents the spreading of COVID-19. Also, Dr. Gulaji, Dr. Stedler thrown the light on applications of nanoparticles at present. These lectures definitely motivate to the newly joined researchers, as it is a new branch for the researchers. Lastly, I will say that organizer who have organized first time such an international conference are succeed, and definitely it will be helpful to the researcher working in this field. I will be thankful to Head Department of Physics, Mr. Navle, IPEC Coordinator, Dr. Dhasade, Co-Coordinator, Dr. Thombre, and Session Coordinator, Kamble AM. Also, I thanks to Dr. S.B. Kulkarni, Institute of Science, Mumbai, Dr. A.R. Babar, Shankarao Mohite Mahavidyalaya, Aklus, Dr. Kothawale, Shivaji Mahavidyalaya, Barshi, Dr. S.D. Patil, Pratapsiah Mohite Patil Mahavidyalaya, Karmala, acting as a chairperson in different sessions. My special thanks to Dr. R.T. Sabkal, a Vice Chancellor, Vice Principal, Tulsaram. So you will get a chance, sir, to become a Vice Chancellor also. Vice Principal, Tulsaram Chaturchand College, Baramati, who has participated in the valedictory function. Also, I thank to all the participants, paper presenters, and directly, indirectly involved in the conference. Thank you. Thank you, sir, involving in the valedictory function.
Yeah.
Thank you.
Thank you, sir. One important note is here, dear participants, feedback link is provided to you on your register email and Telegram group. For getting the participation certificate, filling the feedback form is mandatory. Okay. Then now I request to head of the department, Professor B.B. Navle, to propose the vote of thanks.
Okay, I am audible.
Yes, sir. Yes, it's audible.
Welcome everybody. I am honored to have opportunity to give vote of thanks on the occasion of valedictory function of 2 days International e-conference on recent trends in nanomaterials and its application. Vote of thanks to respected chief guest of this function, Dr. R.T. Sapkal sir, Vice Principal, TC College, Baramati, for giving excellent and informative speech on nanotechnology. I would like to express our deep gratitude to our chairperson, Principal Dr. S.B. Jundle sir, for expressing summary of our conference and their great thoughts. I would also thanks to active and intelligent our convener of this international conference, Dr. J.V. Thombre sir, IQAC coordinator Dr. S.S. Dhasade sir, and organizing secretary Professor A.M. Kamble sir, for successfully arranging this great event. Finally, I thank to all participants for your cordial support and for making this event success. Thank you. Now over to Kamble sir.
No, thank you, sir. On the behalf of organizing committee, Department of Physics, in collaboration with Internal Quality Assurance Cells, organizing International E-Conference on recent trends in nanomaterials and its application 2021. And the President of Valedictory Functions, I declare the function is over.
Namaste.
Here is one announcement related to feedback forms and certificates. The feedback form will be, the link of feedback form will be shared in a Telegram group, and the recorded videos of this conference will be shared with Telegram group only. The published proceeding, that is the research articles published in the proceeding, will be shared via email only. So at the end, I thanks to all. Thank you.